This is solutions for chemistry model examination number 4 grade 12 students. Choose the correct answer from the given alternative and give the answer of your choice on the separate answer sheet. Question number 1. A solution which has the capacity to dissolve more solid is called A. Unsaturated, B. Supersaturated, C. Saturated, D. Concentrated. Solution. A saturated solution is a solution in which the dissolved and undissolved solids are in dynamic equilibrium. Unsaturated solution is a solution that contains less dissolved solid than a saturated solution does. It has the capacity to dissolve more solid to be saturated. A supersaturated solution contains more dissolved solid than a saturated does. It is unstable. It can be converted into a saturated solution by adding a small seed crystal. How to form unsaturated, saturated and supersaturated solution of sodium chloride in water. This is for illustration. The solubility of sodium chloride in water is 36 gram per 100 gram water at 20 degrees Celsius. Here there are 3 beakers, beaker A, beaker B and beaker C. Beaker A, B and C contains the same amount of water. The amount of water in all the 3 is 100 gram. The difference is the amount of the solute. Look at B. B contains 36 gram sodium chloride in 100 gram of water. This is the solubility of sodium chloride in water. And B is saturated solution. We compare A and C relative to what? B. The amount of the solute in A is less than the amount of sodium chloride the solute in B. This implies A is unsaturated solution, and the amount of sodium chloride in C is greater than the amount in the saturated solution B. This implies C is supersaturated solution. Therefore, the answer must be A. Question number 2. According to Henry's, at a fixed temperature, the amount of a gas dissolved in a given quantity of solvent is proportional to the A. partial pressure of the solvent, to B. total pressure of the solvent, C. partial pressure of the gas in the solution, D. partial pressure of the gas above the solution. Solution. Henry's law explains about the quantitative relationship between gas solubility and pressure. It is stated that the solubility of a gas is directly proportional to the partial pressure of the gas above the solution. Therefore, the answer for question number 2 should be D. Question number 3. Which of the following is least soluble in water? A. Sodium bromide, B. Ammonia, C. Methanol, D. Methane. By the principle called like dissolves like, polar covalent molecules and ionic compounds dissolved in polar solvents like water, non-polar covalent molecules dissolved in non-polar solvents like benzene in carbon tetrachloride. According to this equation, sodium bromide is ionic compound, therefore it is dissolved with polar solvent. NH3 is polar covalent molecule and it can form hydrogen bonding with water, therefore it can be soluble with water. CH3OH is polar, in some extent it's a polar covalent molecule, therefore it also dissolved or miscible with water. CH4 is a non-polar covalent molecule. It is dissolved in non-polar covalent solvents. Therefore, methane is the least soluble substance according to the given alternatives. Therefore the answer must be D. Question number 4. The Henry's law constant for N2O in water at 25 degrees Celsius is 2.32 times 10 to the power of minus 2 mole per liter per atmosphere. Calculate the solubility of N2O in molarity in a gas mixture at a total pressure of 1.1 atmosphere containing 0.20 mole fraction N2O. The vapor pressure of pure water at 25 degrees Celsius is 0.03 atmosphere. A 1.1 times 10 to the power of minus 1, B 4.6 times 10 to the power of minus 2, C 5.1 times 10 to the power of minus 3, D 2.6 times 10 to the power of minus 2. Question number 5. How many milliliters of 0.32 molar solution of glucose C6H12O6 in benzene are needed to have 28.8 gram of glucose? The atomic mass of each atoms, carbon, hydrogen, and oxygen are given. A 500, B 455, C 438, D 576. Given we have the molarity, which equals to 0.32 molar, and the given mass of the solute is 28.8 gram, and the molecular mass of glucose is 180 gram per mole. Required volume in milliliter. Solution molarity equals to number of moles of the solute divided by the volume of the solution, and which equals to given mass divided by volume multiplied by the molecular mass of glucose. That means 0.32 molar equals to 28.8 gram divided by volume multiplied by 180 gram per mole. And rearrange this equation to give volume equals to 28.8 gram divided by 0.32 mole per liter multiplied by 180 gram per mole. This gives 0.5 liter. 0.5 liter equals to 500 milliliter. Therefore the answer should be A. Question number 6. Question number 7. What is the mole fraction of ethylene bromide CH3CH2Br in a solution at 85 degrees Celsius equilibrium with 50-50 moles in the vapor? A 0.577, B 0.423, C 0.500, D 0.750. Solution. Ethylene bromide in liquid form exists in equilibrium with ethylene bromide in gaseous form. Both exist in equal amount, so let X is the mole fraction of one of the two forms of ethylene bromide, the liquid or the gas form. Therefore the mole fraction of ethylene bromide in liquid form plus the mole fraction of ethylene bromide in gaseous form equals to 1. Both exist in equal amount, therefore x plus x equals to 1 and 2x equals to 1. X is 0.5. Therefore the answer must. Question number 8. How many milliliters of 1 molar H2SO4 is required to neutralize 10 ml of 1 molar sodium hydroxide solution? A 2.5, B 5.0, C 10.0, D 20.0. Given we have M1 1 molar and V1 is required, M2 also is 1 molar and V2 is 10 ml. And solution, apply the dilution principle, which is M1 V1 equals to M2 V2. M1 rearrange this formula to obtain this one. V1 equals to M2 V2 divided by M1, and V1 is equals 1 molar multiplied by 10 ml over 1 molar. This molar cancelled by molar, and this gives what 10 ml of the solution. the volume of the solution is 10 ml. Question number 9. How many chloride ions are in 1.0 mole of calcium chloride? A 3.01 times 10 to the power of 23 chloride ion, B 6.02 times 10 to the power of 23 chloride ion, C 1.81 times 10 to the power of 24 chloride ion, D 1.2 times 10 to the power of 24 chloride ion. Solution: calcium chloride dissociated in water to give calcium 2 plus and 2Cl minus. That means from this balanced chemical equation, 1 mole of calcium chloride dissolved to give 1 mole calcium ion and 2 mole chloride ion. From 1 mole calcium chloride we can obtain 2 mole chloride ions. 1 mole of chloride ion contains Avogadro number of chloride ions. 2 mole of chloride ion will give question mark and then crisscross 2 mole of chloride ion multiplied by 6.02 times 10 to the power of 23 chloride ions divided by 1 mole of chloride ion, which gives 1.204 times 10 to the power of 23 chloride ions, will be obtained from the dissociation of 1 mole of calcium chloride. The answer is D. Question number 10. What is the normality of 2.3 molar H2SO4 solution? A 1.15 normal, B 2.3 normal, C 4.6 normal, D 6.9 normal. Given we have 2.3 molar and the solution is sulfuric acid solution. Sulfuric acid dissociate to give 2H plus and SO4 2 minus. The total positive charge is 2 times positive 1 equals to 2, Z equals to 2. We are asked to calculate the normality of the solution. Normality is directly proportional to what? Directly related with the molarity of the solution and the total positive charge. Therefore, normality equals to Z times molarity, and normality equals to 2 times 2.3, and normality is 4.6 normal. The answer should be C. Question number 11. An amphiprotic species is a molecule or ion that can A. accept protons, B. donate more than 1 proton, C. both accept and donate proton, D. be formed into a double ion. Okay, solution. Amphiprotic species are species that can donate a proton when they react with a base, and they accept a proton when they react with an acid. Question number 4. The Henry's law constant for N2O in water at 25 degrees Celsius is 2.32 times 10 to the power of minus 2 mole per liter per atmosphere. Calculate the solubility of N2O in molarity in a gas mixture at a total pressure of 1.1 atmosphere containing 0.20 mole fraction N2O. The vapor pressure of pure water at 25 degrees Celsius is 0.03 atmosphere. A 1.1 times 10 to the power of minus 1, B 4.6 times 10 to the power of minus 2, C 5.1 times 10 to the power of minus 3, D 2.6 times 10 to the power of minus. Question number 12. Which species is amphiprotic? A H2S, B HS minus, C Cl minus, D HCl. Solution. H2S is a diprotic weak acid. It can only donate proton. That means it doesn't accept any proton from any sources. B. HS minus can donate and accept a proton. HS minus gives H plus and S2 minus, and HS minus plus H plus gives H2S. This implies HS minus donate a proton here, and in the second example, HS minus plus H plus, that means HS minus accepts H plus to give what? H2S. C, Cl minus only accepts a proton because it doesn't has a proton to donate. D, HCl is monoprotic strong acid. It can only donate a proton. It doesn't accept. The answer should be B. This is solutions for chemistry model examination number 4 grade 12 students. Choose the correct answer from the given alternative and give the answer of your choice on the separate answer sheet. Question number 14. What is the conjugate acid of HPO4 minus 2? A H3PO4, B H2PO4 minus, C H3O plus, D PO43 minus. The solution: HPO4 minus 2 gives H plus plus PO4 minus 3. HPO4 minus 2 donates H plus to give H plus plus PO4 minus 3, and PO4 minus 3 accepts H plus to give HPO4 minus 2. This implies HPO4 minus 2 is bromocellularic acid, and PO4 minus 3 is the conjugate base of what? The acid HPO4 minus 2. The answer should be D. Question number 15. Which of the following is the concerning is acid-base reaction? Here is the acid-base reaction. HS minus plus CH3Cl gives CH3SH plus Cl minus. CH3Cl is a bromocellularic acid. Choose A. Choose B. HS minus is a bromocellularic acid. C. HS minus is a Lewis acid. D. HS minus is a Lewis base. Solution: HS minus plus H3Ca gives H3SH plus Cl minus. In this reaction, the bond between H3Ca is clipped to give H3 plus plus Cl minus. This implies H3 plus has difference of electron, therefore it is what? Lewis acid. HS minus, in HS there is what? One excess electron. This implies HS minus is Lewis base. The answer should be D, because HS minus is a Lewis base. Question number 16. Which of the following gives pH greater than 7 when dissolved in water? A. Calcium chloride, B. Ammonium chloride, C. Sodium fluoride, D. Sodium nitrate. pH greater than 7 means a solution of what? Base, or pH greater than 7 means basic solution. The solution is basic solution. calcium chloride is the salt of the weak base, calcium hydroxide, and hydrochloric acid is strong acid. Therefore, the solution of calcium chloride is acidic. B is ammonium chloride. Ammonium chloride is formed by the combination of ammonium hydroxide and hydrochloric acid. Therefore, ammonium chloride is the salt of the weak base and strong acid, hydrochloric acid. Therefore, the solution of ammonium chloride is acidic. C, sodium fluoride. Sodium fluoride is the salt of sodium hydroxide and hydrogen fluoride. Sodium hydroxide is strong base and hydrogen fluoride is weak acid. Therefore, the salt of the strong base and the weak acid solution is basic solution and pH value is greater than 7. D, sodium nitrate is the salt of the strong base sodium hydroxide, and NO3 is the sodium nitrate is the salt of the strong base sodium hydroxide and nitric acid. Sodium hydroxide is strong base, HNO3 also is a strong acid. Therefore, sodium nitrate is the salt of strong acid and strong base. This gives neutral solution. Therefore, the answer should be C. Question number 17. If a 1.0 mole per liter solution of a monoprotic weak acid is 5% ionized, its dissociation constant is A 0.9 times 10 to the power of minus 2, B 2.6 times 10 to the power of minus 3, C 1.5 times 10 to the power of minus 2, D 1.0 times 10 to the power of minus 1. Given, let HA is the monoprotic weak acid. The concentration of HA is 1 mole per liter, which equals to 1 molar. 5% of HA is dissociated into H plus and A minus. That means the concentration of H plus equals to the concentration of A minus, which is 0.05 times 1 mole per liter. This gives 0.05 mole per liter, which equals to 0.05 molar. Required acid dissociation constant Ka is how much? Solution. Monoprotic weak acid HA is dissociated, slightly dissociated to give H plus plus A minus. The initial concentration of HA is 1 molar, and initially we do not have H plus and A minus concentration. Therefore, the concentration of H plus is 0. The concentration of A minus equals to 0. Change in concentration, which means the amount of the weak acid HA ionized into what? H plus and A minus, which equals 0.05 molar, dissociate to give 0.05 molar H plus and 0.05 molar A minus. The equilibrium concentration is the net concentration of the acid HA, which equals to 1 minus 0.05, and the concentration of H plus is 0 plus 0.05, which equals to 0.05, and the concentration of A minus at equilibrium is 0 plus 0.05, which equals to 0.05 molar. Then Ka equals to the concentration of H plus times the concentration of A minus divided by the concentration of the weak acid HA, which equals to 0.05 times 0.05 over 1 minus 0.05. This gives 0.0025 divided by 0.09, which approximately equals to 2.7 times 10 to the power of minus 2. Which one of the following solution is basic? A, the concentration of H plus equals to 2 times 10 to the power of minus 5 molar. B, the concentration of OH minus is 3 times 10 to the power of minus 9 molar. C, the concentration of OH minus is 3 times 10 to the power of minus 7 molar. D, the concentration of H plus is 1 times 10 to the power of minus 8 molar. Solution: in acidic solution, the concentration of H plus is higher than the concentration of OH minus. In neutral solution, the concentration of H plus equals to the concentration of OH minus. In basic solution, the concentration of H plus is smaller than the concentration of OH minus. By applying the formula Kw equals to the concentration of H plus times OH minus, which equals to 1 times 10 to the power of minus. The concentration of H is 2 times 10 to the power of minus 5 molar, which is greater than the concentration of OH minus, and the solution is acidic. B, the concentration of OH minus is 3 times 10 to the power of minus 9 molar, in which the concentration of OH minus is smaller than the concentration of H plus, so that the solution is acidic. C, OH minus concentration E equals to 3 times 10 to the power of minus 7 molar, in which the concentration of H plus is approximately equals to the concentration of OH minus, so that the solution becomes neutral. D, the concentration of H plus is 1 times 10 to the power of minus 8 molar, in which the concentration of H plus slightly smaller than the concentration of OH minus, so the solution becomes basic. How to form unsaturated, saturated and supersaturated solution of sodium chloride in water? This is for illustration. The solubility of sodium chloride in water is 36 gram per 100 gram water at 20 degrees Celsius. Here there are 3 beakers, beaker A, beaker B and beaker C. Beaker A, B and C contains the same amount of water. The amount of water in all the 3 is 100 gram. The difference is the amount of the solute. Look at B. B contains 36 gram sodium chloride in 100 gram of water. This is the solubility of sodium chloride in water, and B is saturated solution. We compare A and C relative to what? B. The amount of the solute in A is less than the amount of sodium chloride the solute in B. This implies A is unsaturated solution, and the amount of sodium chloride in C is greater than the amount. Question number 16. Which of the following gives pH greater than 7 when dissolved in water? A. Calcium chloride, B. Ammonium chloride, C. Sodium fluoride, D. Sodium nitrate. pH greater than 7 means a solution of what? Base, or pH greater than 7 means basic solution. The solution is basic solution. Calcium chloride is the salt of the weak base, calcium hydroxide, and hydrochloric acid is strong acid. Therefore, the solution of calcium chloride is acidic. B is ammonium chloride. Ammonium chloride is formed by the combination of ammonium hydroxide and hydrochloric acid. Therefore, ammonium chloride is the salt of the weak base and strong acid, hydrochloric acid. Therefore, the solution of ammonium chloride is acidic.